Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 6 Trigonometric Functions Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Sketch the graph of y equals to modulus 2 sine 2x for 0 less than equals to x less than equals to pi. So this is the range of the graph. Continue to read the question. Determine the equation of a suitable straight line to solve the equation pi modulus sine 2x equals to pi minus x for 0 less than equals to x less than equals to pi. Continue to read the question. Sketch the straight line and hence state the number of solutions to the equation pi modulus sine 2x equals to pi minus x for 0 less than equals to x less than equals to pi. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us begin our discussion. Okay, in case if you are wondering why suddenly there is a diagram over here, okay, there is a reason, guys. Okay, I'm showing you the step-by-step working on how to get the sketch of the graph y equals to modulus 2 sine 2x. Okay, in reality you no need to show this much of step, you just have to show the final output, which in this case the y equals to modulus 2 sine 2x only. Okay, the reason why I'm showing this much of step so that you can able to understand better. Okay, so from here, as you take a look at the first graph, this is the simplest graph that you can possibly have for a sine. Okay, where y equals to sine x, there is no additional modulus or additional frequency applied over here. So in this case, you have one complete cycle with a modulus of 1 and negative 1. Okay, of course the negative 1 is the opposite magnitude. Okay, so from here you have one complete cycle. Okay, so this is for the first sketch. Okay, moving on to the second sketch where you have y equals to sine 2x. Okay, slightly different from the first diagram. Instead of one complete cycle, now you have 1, 2. You have two complete cycles over here. So this is the difference between sine x and sine 2x. Okay, moving on to the third diagram. Instead of sine 2x, now you have y equals to 2 sine 2x. Okay, there is an increase in modulus. Okay, compared to the previous sketch, now you have a larger graph. Okay, your graph is bigger now. Okay, instead of 1 you have 2 as your modulus. Okay, 2 and negative 2 as your modulus. Okay, so that's why you have this big sketch. So this is how it looks like when your graph becomes 2 sine 2x. Okay, now what if from 2 sine 2x it becomes modulus 2 sine 2x? Okay, you should remember the concept of modulus, guys. Whatever value you key in, positive or negative, eventually the output will become positive. Every value will become positive. Okay, all this negative value will be becoming positive, will be appearing up. Okay, so from here, let me sketch over here, guys. Since in the question it mentioned the range of 0 up to pi, not 2 pi, guys. So make sure you be careful on reading the question. Okay, so from here, let us perform the sketch now. Since they're finding for modulus 2 sine 2x, so this is how it looks like. Okay, okay, so this is how your graph should looks like. Okay, we can remove the negative region since we don't use it anymore. Okay, it's just nice. So from here, let us proceed to the next step. Our next step will be determining the equation of a suitable straight line to solve the equation pi modulus sine 2x equals to pi minus x for the range 0 up to pi. Okay, so we have already sketched the graph. Now we can proceed to come up with the suitable straight line equation. Okay, so since y equals to modulus 2 sine 2x. Okay, if you take a close look in the equation over here, it mentioned here sine 2x. So we need to change this expression from 2 sine 2x into sine 2x. So how are we going to do that? Okay, it is very simple, guys. You divide the whole equation by 2. Okay, you divide the whole equation by 2. So from here you get y over 2 is equals to modulus sine 2x. Okay, so this will be your first equation. So let me label this as an equation number 1. Okay, as for the second equation, we're going to write down the equation given by the question. Okay, so from here, pi modulus sine 2x equals to pi minus x. So this will be your second equation. So for the next step, what you're going to do is we're going to substitute the equation 1 into the equation 2. Okay. Let us continue. So from here, you should get pi. Instead of writing modulus sine 2x, now it will become y over 2, okay, close bracket, equals to pi minus x. Okay. So from here, you times in. So from here, you should get pi y over 2 equals to pi minus x. Okay, remember guys, at the end of this working, you should form a straight line equation such that it fulfills the straight line equation form where y equals to mx plus c. Okay, I hope you guys are clear about this. So from here, for the next step, what you're going to do is this 2 we're going to times with pi minus x. So from here, pi y will be equals to 2 pi minus with 2x. Okay, so for the next step, what you're going to do is we're going to divide the whole equation by pi. So from here you get your equation y equals to 2 minus 2x over pi. Okay, you rearrange this equation such that it fulfills the form y equals to mx plus c. So from here it will be y equals to negative 2 over pi x plus 2. Okay, in this case, negative 2 over pi is the gradient of the straight line. The 2 will be your y-intercept. So this is the second step, guys. Okay, let me underline this. For the third step, what we're going to do is we're going to sketch the straight line into the graph, and then we're going to find how many solutions that we can possible form. Okay, so from here what we're going to do is we're going to need 2 points, okay, from this straight line. Okay, so from here what we can do is we can set our x value equals to 0, where in this case we're going to find our y-intercept. That is the easiest point that we can possibly find. So from here, when x equals to 0, okay, when you substitute your x equals to 0, so from here you get your y equals to 2. Okay, and then the second point you can possibly substitute is the x equals to pi. Okay, that is the easiest point. So from here, when x equals to pi, okay, when you substitute the x equals to pi, so from here y will be equals to negative 2 over pi, okay, and then you times with pi, okay, and then plus with 2. So from here the pi will cancel off, So from here negative 2 plus with 2, from here you should get your y equals to 0. Okay, so in this case this is your x-intercept and this is your y-intercept. Okay, so these 2 points we're going to plot in this diagram that you have early sketched on. Okay, so these are the 2 points. Okay, this is the first one, the y-intercept, and this is the second one, the x-intercept. Okay, now what you're going to do is we're going to draw a straight line. Let me draw the straight line now. Okay, from here we need to calculate the number of intersection points. Okay, let us calculate together. So from here 1, 2, 3, okay, and the last, this also counted guys as an intersection point, in this case is 4. So you have a total of 1, 2, 3 and 4 solutions. Okay, so from here your number of solutions will be equals to 4. Okay, so we have already find the 3 solutions. Okay, the first solution is sketching the graph. Okay, and the second solution is forming the equation of the straight line, and the last solution is the identifying the number of solution based on the intersection of straight line and the trigonometric curve. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks or questions, feel free to put down in the comment section. Thank you everyone for your support, and I will see you in the next video.